Hi students, good morning. Okay, today we will go with the new topic that we call as the corner map. Okay, corner map. Okay, let's do before that one. We will have the what is the Boolean function. The Boolean function can be Boolean function. Boolean function. Okay, Boolean function can be what here the two types. One is called as the SOP. That is nothing but the sum of products. It's to be what is the sum of products, and this is the what is the POS, that's in the pause, that's the product of sum. Product of sum. We already studied in the previous class. This is the SOP, this is the POS form. Two types of Boolean function we have. Okay, in that we have the two more type are there. One is called the canonical. Canonical, this is the non-canonical. This canonical is called the standard form. Similarly, in this also we have the two types of Boolean function. That is the canonical form. Another one is the non-canonical form of the Boolean function. Okay, Boolean function. Okay, these are the Boolean function. Okay, one is called the Boolean function. We derived from the truth table. Whichever the term, okay, binary values are high position within the truth table, those to be written terms as the Boolean function. Okay, this is already seen in the last class. Now consider this Boolean function can be two types. One is called the SOP, sum of products form. Another is the POS, that is the product of sum form. Okay, this is called the, sometimes we can say it's what here the Boolean function can be here, the truth table is here. Okay, this is the truth table. X and Y is there, 0 0 0 1 1 0 1 1. If the Boolean function is here, the terms these are the high portion. Okay, remaining cells are what is the 0 0. Okay, then this Boolean function, this combination of the binary value, the Boolean function, Boolean term is, that's the mean term can be here, the what is the value here, the x dash y dash. This to be what here, the having this mean term to be what here, the x y dash, x y dash. Yes or no? This we call as the mean terms. Okay, that's the f of x y is called as the, these are the mean terms. We call as the, these terms are called as the mean terms. Okay, this to be represented with what? Small letter m, small letter m, and also mean terms SOPs are represented with the summation also. We have the mean terms. How many mean terms are there? X dash y plus x y dash is there. Okay, then you can also write this one is the x dash y is what here, the x dash y dash is there, x dash y. This to be what here, the m0 plus this is what here, the m2, because this is binary equivalent, decimal equivalent 0 1 2 3. Okay, these two combinations we have the mean terms in the Boolean function. Then we can also write this one is the summation of m0 m2. Okay, we can also write this one summation of m as outside 0 2. Okay, this is the what we call this SOP form for the two variables, SOP for the three variables, SOP for the four variables also called. Okay, these are the terms, whatever the terms are there, this is the products are there. This we call as the sum of products. We call this what is the sum of products. That's what we call as the SOP, sum of products form we call as the SOP. Similarly, we can also have the POS form. Completely POS is what is the POS is nothing but the product of sum. This is the product of sum is there. Product of sum is not a similar to the same is the similar to the earlier one, but here we will consider that truth table itself. From the truth table itself, wherever the zeros are there, that's to be considered the max terms in the POS. Okay, max terms in the POS. Let me have the max terms is nothing but the 0 1 combination Boolean values, Boolean variables. We have the Boolean combinations as the 0 1. That's to be what is the considered the max term. 0 1 is nothing but the 0 1 is what is the x plus, okay, then the y dash, y is there, y dash is there. One thing you remember, okay, I will teach you. Okay, x, this is the x, where in the SOP we will be having the a dash equals to 1 0, a equals to 1. In the POS form, a dash is equal to what is the 1, a is equals to a dash is equal to 1, a is equals to 0. This is nothing but the SOP POS are the exactly complement to each other. It's opposite to each other. The easier the whatever the combination we have, this one, this to be what is the a dash 1 1. This is to be what. This is nothing but here the x plus y dash, because we are replacing, okay, whatever that 0 is there, that's to be taken as the x, y 1 is to be taken as the complement form, y dash is there. There we are taking the product form, there we are taking the product form, but we are taking in the plus form, r form, that's the xy. That the dot operator is replaced with what is the plus operator. That's nothing but the and will becomes the or. That's nothing but the complement to each other, and in or in. Okay. Then the another term that's called the fourth term, it's the max term, that's to be what here the having the 0 is there, 1 1 is there, that's what we consider as what here the one more is there, that's we call as the what here the one more is that, that's we call as the x dash plus y dash, because we are treating the one as the a dash, that's the 1 as the x dash, okay, 1 as the 1, that's the y dash, that's to be what is that's the Boolean function can be x, f of x equals to x plus y dash plus x dash y dash is that. This is the Boolean function for the in the POS form, okay. This is to be considered as the, if you can write this one as the x plus y dash is what here the capital M. We already told you that here we are using the small m, but here we will be using the capital M. This to be terms are called the max terms, and also the capital M is using, and also POS symbolically we will be using the summation, this pi form, okay, pi, okay. Then the x plus 0, x plus y dash is nothing but what here the x plus y dash is what here the x plus y dash is what is the 2, that's to be what is the m2, okay. This is what here the m3, okay, m3. Then we will be taking the pi as the outside, okay. This is the what here the pi, then the m is the here the this to be taken 2 and 3, okay, 2 and 3. This is the writing of the Boolean function, with the mean terms and max terms from the to table in the SOP and the POS form, SOP and POM. SOP ಅಂದಾಗ 1 1 ಇದ್ದಲ್ಲಿ SOP ಹಾಕೋಬೇಕು, SOP ತಗೋಬೇಕು. ಅಲ್ಲಿ ಎಲ್ಲೆಲ್ಲಿ 0 ಇರ್ತದೆ ಅದನ್ನ ಏನು ಮಾಡಬೇಕು, ತೊಗೋಬೇಕು. ಇದು 0 2 ಐತಿ, ಇಲ್ಲಿ ಏನೈತೆ 3 ಅದ, ಇದು ಇಲ್ಲಿ ಏನು ತೊಗೊಂಡಿದ್ದೀವಿ x y dash is there 3 2 ಆಯ್ತಾ, ಇದೇನು 1 ಆಗಬೇಕಾಗಿತ್ತು. This is what here the 1, this is what here the 1 0 1 0 1, this is to be what 1 1 3, okay. It's complement, wherever we have the 0 2 is the missing term is here, the 1 is there, okay, 1 2 is not, should not be there, here 3 is there, here 3 is not there, 3 is there, wherever the missing term, that is to be considered as the max term in the POS form, okay. This is all about the SOP and POS form, okay. One more thing is I told you, okay, I will be teaching in the proper way. Let me have the difference between the SOP and POS form first. Okay, this is the SOP. This is what a POS. SOP is nothing but the sum of products. POS is nothing but the product of sum. Sometimes we call it SOP, that's to be POS. Okay, sum of products and the product of sum. Okay, here the whatever the terms, okay, we are getting those to be, for example, thus f of x y is to be taken is there, the one function is there, okay, x dash y dash plus x y is there, okay. Okay, this to be what here the whatever the terms we are considering, this to be considered as the mean terms. and the symbolic representation of the mean terms is what is the small m, and this to be whatever the summation is there. This summation can be replaced with whatever the summation of this one, How to write this one is the, we'll see, this is what here the, this is equivalent to m0, this is equivalent to m0. If we go with the truth table x, y, this is 0, 0, 0, 1, 1, 0, 1, 1. This is what here the 0, 1, 2, 3. Okay, if it's the x dash y dash is there, x dash y dash is 1, this is the x y is there, remaining cells are, remaining terms are 0. Wherever the function is high, that is to be considered in the mean terms in the Boolean function. Okay, this is called as the m0. Okay, this is called as the m0, m1, m2, m3. Whichever the, wherever the present is the high is the f of function is high, that is to be taken as the in my Boolean function. m0 is there, m3 is there. Because I have taken the summation here, summation form, that is what I am not taking this summation. Then I can also write the f of x, y. This is to be f of x, y. F of x, y is the summation of mean terms are there. Take the mean as m as outside. This is to be what is the 0, 3. Yes, so if any term is in the missing terms are there, that is to be added with the if my function is having the mean terms, that's the non-canonical form, that is to be missing variable is in the term, that is to be added with the a plus a dash if a is missing in the term. If it's a b is missing, that is to be what is the b plus b dash to be added here. Like this will be having this one from the SOP form. Come to the POS form. Okay, if the POS form f of x, y, then the POS form is nothing but the wherever the 0 is there, that is to be considered the max terms are there. Okay, let me write the max terms with the Boolean function of the POS form. 0, 1 and 2 is there. 1 and 2 is there. 1 and 2 is nothing but this is what here the 0 is to be considered as the, this here the a is to 0 is to be considered as the a dash, 1 is considered as the a. But here the similarly here the in the POS side 0 is considered as the a, and 1 is to be considered as the a dash, completely opposite each other. That's what the wherever the 0 is there, that's to be considered the max terms. Okay, this 0, 1 is there, then it's to be considered as what is the 0, 1. 0, 1 is nothing but it's a x dash y in the SOP, but here the x y dash is there, x y dash, but there you are using the product form, but you will be using the plus symbol here. Okay, one more max term is here, we can also write here also x, y, f is there. Okay, 0, 0, 0, 1, 1, 0, 1, 1. This to be what here the 0, 0. Okay, this is what m0, m1, m2, m3. 0 is there, where is the m3 and m2 is present. Okay, that's what we will be writing. This one is the combination as what here the x. This is the x. A is to be considered as the a dash is considered as the 1, a is to be considered as 0. Okay, that's what we will be having the combination here. This is the combination I would be going. Okay, this is combination I will be going here. Okay, that's what they are. X y dash is there, x y dash, x plus y dash is there. Then this is what is x dash y plus, okay, then x dash plus y. This is the max terms present in the my POS form. Okay, I hope you are following this one. Okay, I hope you all are following this one. Okay, this is the decimal to 0, 1, 2, 3. Okay, next is what are the terms we are getting here. What are the terms we are getting in the POS? What we call as the whatever the terms we are calling, this to be called as what is the max terms, capital M, max terms. Okay, then the whatever we got the max terms, those max terms will be represented with the capital M. Okay, then here we are using the summation sigma, but here we will be using the pi for the complete POS representation. And also we have the, for example, whatever the function will be, this can be written as the f of x y equals to, this to be written as the m, this what is the m1 m2, this to be m1 plus m2. Okay, this to be replaced with the equivalent max term representation m1 m2. Okay, this to be written as the f of xy equals to, this is the pi, I am taking this one. Okay, this is the product, not a plus symbol, because we don't have the plus here. Product is there, product is there. Then I am taking this one pi come completely in this form of in this form. Okay, that's to be what is the, then the pi of m equals to 1 2 is there, 1 2. Okay, this is the same representation of the Boolean function with the SOP form pi sigma of m 0 over 3. This is it's here, which is the missing term here. 1 and 2 are there. Just I am taking the 1 or 2 on the max terms as the max terms, then the pi of m. This is nothing but here the completely our terms are completely whatever the max terms and mean terms, whatever you taking from the SOP to the POS, from the mean terms, those are the mean terms are there. Those are leaving that one, we will consider the max terms in that one for this one. This is we call the difference between the SOP and the POS form. Okay, I hope you all following this one. Yes or no? Okay. Okay, this is all about the SOP and the POS form. Okay, next we'll go with the simplification of the Boolean function with the help of we have seen already in the last class. Okay, simplification of the Boolean function with the help of what? Boolean laws. Boolean laws are what? Boolean theorems and the postulates. Okay, theorems will be proofing out. Okay, these postulates already these are the, we don't need proofing over there. Okay, while using these Boolean theorems and laws, we simplified the some Boolean functions with the in order to get the reduced form of the designing of the logic design. Okay, will be this Boolean function simplification will be done with the help of the Boolean theorems up to the 3 variables. Up to the 3 variables. If I have the 2 variables in that, I can also easily simplify it with the that Boolean function with the help of the Boolean laws. If I have the 3 variables in the Boolean function, that one also I can easily simplify with the Boolean laws, that's the theorems and postulates. While using the some theorems are there, no, distributed law, associative law, identity law, so many are there like this. Okay, De Morgan's law. So while using such a laws, we have simplified the Boolean function, but it's restricted only to the what? How many variables? 3 variables. In order to overcome this problem, we will come up with the other techniques are there. Those are what called as the KMAP. Another one is the McCleskey method. Okay, Pin-McCleskey method. Pin-McCleskey method is there, and other algorithm also there. But for your syllabus, we have the KMAP up to the 4 variables. But I can have this, I can simplify the Boolean function with the up to the 6 variables with the help of the KMAP. But for your syllabus, we have the only the KMAP with the what are the 2 variables, 3 variables, 4 variables. But I can also simplify the 5, 6 also by using the KMAP. Okay, KMAP. Okay, but this is not your syllabus. Okay, Pin-McCleskey method is there. Pin-McCleskey method is there, but this is not used in the for your syllabus. And also we have the some algorithms are there. Some algorithms also there. We will not be using these two. Okay, these two. But for your syllabus, KMAP is the for 2 variables, 3 variables, and 4 variables. KMAP is there. Now come to the point. What is the KMAP? What is the KMAP? KMAP is the one of the technique. Okay, one of the technique which will transfer the complete truth table to complete truth table. Okay, complete truth table to what here the complete truth table to what the grid form, that we call the KMAP. The KMAP is this is called to sometimes called as the grid, skeleton, or else we can also make as a map also. Map also. Okay, whatever the, it's completely, it's the tabular form. Okay, whatever the we have the rows and column in the truth table, no, that is to be completely transferred to where in the form of grid form. Okay, with the help of the KMAP. In the simplification of the Boolean function, we will be using the some laws. Those laws made here the rules. Those laws, whatever the laws we are using, those to be made here the rules here. Okay, simplification of the Boolean function with the help of the KMAP. We will see the 2 variables, 3 variables, 4 variables also. Okay, this is the completely transferring the to table 2 in the form of grid form. Okay, this was invented by the Karnaugh map. Karnaugh, that's what they given the name as the Karnaugh. Okay, we'll see one by one. First one is consider the what is the necessity of the KMAP. Okay, the KMAP is necessity to avoid the human errors. While simplification of the Boolean function with the help of the Boolean laws and theorems, we are using the some more techniques over there, like we should have to remember advanced version of the advanced remembrance purpose we need there. Okay, how to remember the Boolean laws and theorems, so somewhat it's tricky. That's what we come up with a new solution that's called the KMAP. KMAP. Okay, got it? In the KMAP, we have the some rules. Those rules are made from the theorems only, but instead of remembering theorems, we made those as the rules here. That's it. Okay. One more thing is there, KMAP. Okay. While if I use the KMAP, we can avoid the human errors. There we are making the human errors while simplifying the identifying the and also variables and also applying the theorems, applying the postulates. We'll be using the making the so many errors over there. We can avoid those errors with the help of what here the KMAP while applying those Boolean laws and theorems as itself as the laws are the rules of the KMAP. Okay, got it? I hope you are following this one. Okay, next we'll go with come up with the we'll go with the KMAP. Okay, KMAP with the 2 variables. Okay, shall I erase this? Shall I erase this? Yes. Okay. Okay, then go with the we'll come with the new topic, that's the KMAP. KMAP also we have the in this also we have seen the Boolean function in the Boolean equation. We have the 2 forms, that's the SOP and POS. Okay, in this we have the meaning canonical, non-canonical. In this also canonical, non-canonical. But we have seen the SOP. We'll consider from the Boolean function simplification with the help of the KMAP in the form of SOP form only. Then canonical, non-canonical. Then we'll move to the next as the POS canonical, non-canonical. First in the SOP form we'll see the 2 variables, 3 variables and 4 variables. Canonical, these are what is the canonical, non-canonical also we'll see one by one. First I'll go with the 2 variables KMAP. 2 variables KMAP. We'll see the step by step. Okay, step by step procedure to KMAP simplification by the to the 2 variables KMAP. 2 variables KMAP. Okay, 2 variables KMAP. First one we consider the 2 variables KMAP. First, okay, step by step procedure. Okay, first step is to you have a general. First step is to identify the number of. First step is what is the in general. Okay, first step is the identify the number of variables. First we need to identify the number of variables present in the Boolean function, given Boolean function. Next step is what? After we identify the number of variables present in the variables Boolean function, step 2 is what is the design. Okay, designing of the KMAP. If let's say 2 variables, I will 2 to the power of n number of it's nothing but 2 to the power of n number of cells I need here. If I example, for example, 2 to the power of 2 is there, 2 variables, then I would go with the 4 cells of KMAP. If it's a what here the 3 variables KMAP, then I will go with the 8 cells KMAP. If it's a 4 cells, 4 variables are there, then I will go with the 16 cells of KMAP. Yes or no? Okay. Okay, this is all the KMAP. Okay. First KMAP with the step by step procedure to simplify. Okay, not a 2 variables, don't consider. And first identify the number of variables, then design the KMAP. Okay, according to the number of variables. If the 2 variables, then 4 variables, 4 cells of KMAP I need to design, 8 cells of KMAP I need to design. If it's a 4 variables, then I will design the 16 cells of KMAP over here. Okay, how to design? Next step is to okay, designing. First step is what is the number of cells. Okay, number of cells are there. Which are those number of cells? 2 cells are there, then the 2 variables are there, then the 4 variables cells I need the KMAP. Okay, 4 variables KMAP I need here. If it is a 3 variables KMAP, if it is a 3 variables, then the 2 to the power of cells, 8 cells of KMAP I need here. Then the 8 cells of KMAP I can design here. Yes or no? Yes or no? Okay. Similarly, if I have the 4 variables KMAP, 4 variables in my Boolean function, then the 2 to the power of 4 cells of 16 cells of KMAP I need to design here. Yes or no? Okay. Yes sir. Okay. This is the 2 variables, 3 variables, 4 variables. Okay, this is the designing of the designing of the KMAP. Next step is to what here the step 3. Step 3 is what here the okay. Then divide the this grid in the rows and column. Okay, let us consider the x and y are the 2 variables in my 2 variables KMAP. Okay, x is the on the row side, y is the column side. Yes sir. Then what is the x is this can have the 2 values. If I tilde a coin, how many combinations can I have? 2 combinations. Okay, that's to what is the 0 or 1. That you can also write this what 0 is to be what x dash, x 1 is to be written as the x. I can also have the 2 values 0 or 1. This to be what y dash, this is to be y. Then the indexing of the cells. Next step is the step number 4. Okay, indexing of the cells means what? Indexing of the cells means this is what we call it completely grid or skeleton or map ಅಂತ ಕರಿತೀವಿ. ಇವು ಏನಂತೀವಿ ನಾವು ಸ್ಕ್ವೇರ್ ಅಂತ ಕರಿತೀವಿ ಅಥವಾ ಸೆಲ್ ಅಂತ ಕರಿತೀವಿ, ಅಲ್ಲ ಇಲ್ಲಾಂದ್ರೆ ಬಾಕ್ಸಸ್ ಅಂತ ಕರಿತೀವಿ. ಬಾಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಲೆಟ್ ಇಟ್ ಬಿ ಹಿಯರ್ ವಾಟ್ ಇಟ್ ಮೀನ್. Okay, next is identifying indexing of the cells based on what is the multiplying with the row with column. Okay, you can also draw with this one as the x y 0 0 0 1 1 0 1 1. Okay, this is what is 0 0 0 0 is what here the decimal equivalent 0 1 2 3 is 0 0 1 is the 2 0 1 is what equivalent 1 1 0 is what here the 1 0 is 2 decimal equivalent 2 1 is what here the 1 with multiply with 1 with 1 with 3. This is what here the x dash y dash. This is what x dash y. This is what x y dash. This is what x y. This we call as the mean terms. Okay, this are called as the mean terms. Which are those mean terms here? The m0, m1, m2, m3. Okay, we can also write this one is equivalent as same as the even you can also write this one is the equivalent, or else you can also replace. Okay, in this also same as you can also write here the 0 1 2 3. This is the x y. Instead of writing this, okay, I can also write this one as the m0 m1 m2 m3 also. Yes or no? Okay, these are the called as the what we call as the mean terms, which are the present in the mean term. If this is what designing of the KMAP for the 2 variables, and also mapping. Okay, then the grouping of the cells. if the if my function is having the any variable, okay, if my function is having the any of these cells to be 1, terms to be filled with 1, remaining cells as the 0. Let me have the function here, the f of x y is there. Then the I can also write this one is there, what here the if x dash y dash plus x y is there. X dash y dash is what here, the x dash y dash is 0. 0 is nothing but this is to be written as the 1. Function is to be considered as the here the 1, f equals to okay the 1. Okay, next is what x y is there. X y is there 1. Remaining cells are what 0. Okay, this is to be combination. This is nothing. The m0 is wherever the m0 is there, just to put the 1 over there. Wherever the 1 over there. Okay, and m3 is also having the 1. Remaining cells are here the 0. Remaining cells as the 0 because the m1 is 0, m2 is 0. Okay, then the combination. Okay, these two cells are independent to each other. Okay, the application of the applying the grouping techniques only to the horizontal. Either to be horizontal, we should have to identify the cells which are adjacent to each other. Next step is the grouping of the cells with the adjacent to each other. These cells are not adjacent. Okay, one thing you remember, KMAP always rules is that we should have to make the groupings either horizontal or vertical. Horizontal or vertical. But here we have the only these two cells are what diagonal to each other. We can't make the group, so that we will go with the independent cells. Then we to what here the minimize. Okay, this is what is having the this group belongs to only one row, that is called the x dash. This group belongs to only one row column, that is called as the y dash. Then this group belongs to only one row, that is called as the x. This group belongs to only y, only one row column, that is called as the y. Then the simplified form of the f of x y is nothing but the what we have the value here. What do we have the value here? Xy plus x dash y dash. This is what is the values here. Okay, this is the simplified of the same as it is. Okay, that's nothing but here the simplification Boolean function based on what here the number of cells which are adjacent to ones which are adjacent to each other. These cells are not adjacent, so that we will be not simplifying the values whatever we have the same as it is we are keeping here. Okay. Yes, if I go with the three variables, okay, then I can design this one is the what here the okay. Let me consider the one more example for the two variables. We will discuss with the three variables afterwards. Let me complete the two variables KMAP here. Okay, the two variables can have the this is about the one. Let us consider the one more example. F of x a b. Okay, this is the a and b having the mean terms as the 0, 1 and 3. Okay, he has given directly whatever he has given whatever the things he has given directly only. Okay, if my function is there, let me have the one more function here. F of this is what is x, this is what is the a dash b dash plus a b dash plus a b. Okay, these are the three cells. Okay, these are the three mean terms. Okay, these mean terms can also be written as the this is what here the equivalent to 0 0 1 0 1 1 is there. This is to be what here the m0 m2. This is what m3. Yes or no? Yes sir. Okay, then this to be written as the summation of m0 to 3. Okay, if it's given okay like this, you can also modify this one. You might be asking in the examination from like this also, even you can also like this also, it will be asking, even it can be directly, you can be asking. If it is asked in the examination in the terms, okay, in the mean terms as the with the canonical form, those to be written in the mean terms form, then it is to be transferred with the SOP form, that's with the SOP summation form. Then the design, okay, then the designing of the KMAP. Okay, how many variables are here? 2. Yes sir, okay, 2. Then I will go with the 2 variables KMAP. How many? 2 to the power of 2 means 4 cells KMAP I need here. Okay, 4 cells KMAP means here like this. Then the divide the KMAP, divide the map with the rows with the column side, row and column side. This is row and column, this is row side, this is the column side. Then that take the 2 variables, one variable can be taken to on the row side, another variable taken to on not the column side. In the 0 1 0 1, this is what is the A dash A, is the B dash B. Then the row with column, row with column. Okay, students, today will continue the same the 2 variables KMAP itself. Well, let us consider the one more example we have. Okay, let us to be f of A comma B. Okay, A comma B, that's to be what the having the values as the A dash B dash and A B dash and A B. Okay, this is the example of the 2 variables KMAP. This is the function. Okay, he has given the canonical form, all the in the terms which are consist of the all the literals in the particular term also. Okay, let us to be consider this can be written here the as the here the this is to be what here the this is the 0 0 0 sorry 1 0 1 1. It means what here the I can also write this one as the m0 plus m2 plus m3. Yes sir, yes sir. Okay, that's what in the meantime, so that I can replace with here the summation of m0 comma m2 comma m3, because I'm using the plus instead of using the plus, I'm using the summation. Okay, this is the representation, this is the symbol for the SOP form. Okay, SOP form, this is the sum of products form. Okay, then I will go with the summation of m, I'm taking common. Okay, this is what here the 0 2 3. Yes or no? 0 2 3. Okay, now it's to be considered as the this is the f of A comma B. Okay, this is the equation. Okay, this is the equation we have here. Okay, so that this is the Boolean function with the mean terms here. Okay, this how many variables are there? Identify. First step is to identify the number of variables. Okay, first you have to convert the mean terms. Okay, this is to be correct. Okay, next identify the number of variables. How many variables are there? 2 variables A and B. Okay, 2 variables are there, 2 variables. Which are those? A and B, so that I can have the design the 2 variables KMAP. That's to be what here the 4 cells KMAP, 2 to the power of 2, 2 to the power of n number of cells can I design. 2 to the power of 2 means 4 cells KMAP. KMAP I can design. Yes or no? Yes sir. Okay, then after the designing of KMAP, divide the KMAP into rows and column. Next step is what? Divide the KMAP into rows and column. How to design this one? You have to divide this one. Okay, this is to be on the row side, that's to taken as the A as the on the row side, B on the column side. Okay, then the give the values binary combination. A can have the 2 values either 0 or 1. This to be can be written as the A dash, this to be B, sorry, A only, A only, because it's, B can have the values 0 or 1. This to be written as the B dash, this is B. Okay, then okay, step number 1, step number 2. Okay, now the identify the then the indexing of the cells. 0 0 combination is 0 1 2 3 like this. You know this one. Yes or no? Okay, next identify the then the cells. Okay, means the corresponding cells are mean terms with the corresponding cells are filled with water 1. Remaining cells are what here the 0 only. Then the fill the mean terms whatever the 0 cell is there. What is that? 1. Second is there 1. Third is there 1. Remaining cells are what here the 0. Okay, remaining cells are what here the fill the with the 0. Okay, don't fill 1 because it's not present in your summation SOP form of this Boolean function. Okay, then the identifying the cells with the ones. Okay, next step is what? Grouping of the cells which are the adjacent to each other. How many cells are adjacent to each other? We have to check. Okay, first possibility of the grouping of cells is 2 to the power of n number of cells can be grouped here. How many cells are how many variables? 2 to the power of 2 means how many cells? 4 cells can be grouped here. This we call as the quadrant. Okay, this is to be next step is what I can also group here the pair group also, because it's a low relation, it's one single or independent cell. Okay, is there any possibility to have the 4 cells in the grouping to each other, adjacent to each other? Yes or no? No, because it's a one cell is having the 0, so that we can't go with the quadrant. Okay, next is what? Pair. 2 cells can be adjacent to each other. Just to identify which are those cells. 2 cells. Okay, these are the 2 cells are adjacent to each other. Yes sir. Yes, okay. I left with our one more cell is there. This is the third cell. That's we call it what here the fourth cell that is having the one. Can I make it one? No, because KMAP always try to make the group always with the number of cells should be more in the group. Even the grouping groups can be overlap to each other. Even the groups can be overlap to each other. Okay, this for this grouping purpose I am overlapping the first group. First group, it's possible. This is the one of this rule in the KMAP. Okay, next grouping is of the cells which are having the one says over. Next, minimize the groups. Okay, identify the get the mean terms from the simplified one. This one is the and also from this also. Okay, we will get the first cell. Okay, this is the first group. This first group is belongs to how many rows? 2 rows. This row from this, from here the variable keep on changing its state. The elements are literal or variable which is going to change states from complement to uncomplement, uncomplement complement, that's to be eliminated. That's because we can have the a plus a dash is what? 1. This is the law, identity law. It made what here the rule here. Okay, if any variable is changing its state from the variable that is to be eliminated proper. Okay, the variable which is constant, that is to be taken considered to be while grouping of the minimizing. Okay, next row side we got the only one, that's the one only. Then the column row side, then this group belongs to only one column, that's the having the b is to be what here the b dash state, just 0, that's nothing but the b dash. Then the b dash is here. Okay, next come to the column side. This group belongs to uh, only one row, that is called as the a dash, a dash. Then this group belongs to the 2 columns, that is the b dash and b. The variable b is changing, its keep on changing state. Okay, next consider the f of a comma b. The value is here the a dash, the plus b dash. We got the from this here the we got the answer is what here the sorry a is a only a dash plus b, a plus b dash, we got the answer. Whether we got the answer correct or wrong, we'll check, because of the 2 variables KMAP is the 2 variables boolean function is there. We can identify, we can check the answer with the help of the applying the boolean laws. Okay, get the take this one as the same as it is. Okay, this is on another side. Okay, a dash b dash plus ab dash plus ab. Okay, yes or no? Yes or no? Okay, then apply the take the common element here. Which is the common element here? A dash b plus which is the common literal variable is there? A is common here. B dash plus b, b dash plus b, that's nothing but the b plus b dash is how much? 1. Okay, just to keep as it is, a dash b dash plus a, that's 1, is equal to a dash b dash plus a. Okay, as you can also write the a plus a dash b dash. Okay, apply the distributive law here. Okay, then the multiply these two, multiply these two. Okay, that's nothing but the I can also write this one is the a dot a dash plus a b dash. Okay, yes or no? Sorry, a plus a dash, then a plus b dash.